Kirk Math. All right, here we are trying to finish our study guide for Module 8, going over these questions so that you can either study for your test or your retake wherever you are. We are here looking at the vertical velocity, which right here is the equation, and it is set up very similar to standard form. Vertical velocity is, this formula, which represents vertical velocity, is used in the real world. It is always negative 16t squared for your ax squared. That's just always that way. It just happens in nature. And then the b value is the velocity that the person or thing is kind of jumping or being thrown at. And h, o, sub o, or c, is the initial height that the object's standing. So for example, if let me see if it'll let me. If I am a jaguar and I am jumping, my C, or my initial height, is going to be 0 because I'm standing on the ground. But let's say I'm a diver and I'm diving off a diving board. My vertical velocity will start at whatever tall and height the diving board is. Okay, so this is going to be your HO or your C, H sub O or your C. It depends on where you're starting, okay? And then, of course, your velocity is your speed and direction that you are going. So according to the question for number 11, we already know that a kangaroo has this equation. So the negative 16t squared, which we know is normal, plus 24t. Now there is no c. The c is technically 0 because this kangaroo is standing on the ground. What we want to know is the maximum height after it jumps. So if this is my kangaroo, I want to find that maximum height, which another word for that is vertex. So I need to find the vertex of this parabola. So if this is my formula in standard form, give me the vertex. So all I have to do is my negative b over 2a to find x, and then plug in to find y. So I'm going to do negative 24 over 2 times negative 16. It's going to get me negative 24 over negative 32, and that is going to be kind of a funky number, so let me calculate. So that is going to be 75 hundredths, and that's x, or t in this case, for time. Okay, so t is 0.75, and so what I need to find now would be my y value, or my solution, right, the height in which my is my highest point, because this is the time at which the kangaroo's at the highest point, but I need to plug it back in. So I'm going to take that and plug it back in for t and solve. So I'm basically going to do negative 16 times 0.75 squared plus 24 times 0.75. And I'm going to do that on my calculator here. All right, so when I do it on my calculator, I get negative 9 here, and 24 times 75 hundredths is 18, so that makes 9, and that is why our answer is 9 feet. Okay. Okay, on number 12, we're still looking at standard form, and we're trying to find b. It gives us a graph, and from the graph, I know here's my kind of vertex, and it's kind of hard to see on this graph, and I do apologize for that, but this is a negative 4, this is 4, and this is 8, okay? And so that means that this, my x, is 2, okay? My line of symmetry right there, my axis of symmetry, is 2. So what I need to do is plug in information in order to solve for plug in information in order to solve for b. I know that x is negative b over 2a. Okay, x being the line of symmetry, the axes of symmetry there. So if I know that that axis of symmetry is 2, then I can solve for b by plugging in a, which is negative 1 in this case, because this negative x squared means that that's really negative 1x squared. And then I'm just going to solve. So I'm going to say, okay, this is 2 equals negative b over negative 2. I'm going to times both sides by negative 2. And I'm going to get negative 4 equals negative b times both sides by negative 1. And I'll get 4 equals b. And that is how my answer is 4. Now in number 13, we have our infamous painting surrounded by a frame problem. We're going to write a quadratic function in standard form to represent the combined area of the picture frame, or the picture and the frame. So here we have our picture. That's 11 by 5. Excuse me. I know that this side of my frame is W, and even though my picture isn't drawn perfectly, this side is W, this side is W, and the length of the picture is 11. So the length from here to here is 2 of the frame inches, the widths, plus 11. Then on this side, my picture is still W on each side. That's my frame. And then the picture itself is 5. So this from here to here is 2W plus 5. Now I have two binomials that I can multiply and turn into write in standard form. So I'm going to FOIL this and get 4W squared plus 10W plus 22W plus 55. Put these middles together and you get 4W squared plus 32W plus 55, and it is in standard form. Okay? The function of the area of W is 4W squared plus 32W. Oops. Plus 55. Now, 14 is related to 13 because we want a reasonable domain and range. Obviously, I could get a bunch of different answers because this is going to be a parabola, but answers that are negative don't really make sense because a frame can't have a negative amount, and a picture can't have a negative length. So it tells us that the frame must be at least 1 inch and no more than 3 inches wide. So this frame, W, okay, needs to be, W itself, which is our domain, needs to be at least 1 inch wide, but no more than 3. Once I plug those values into my equation over here, I'm going to do 4 times 1 squared plus 32 times 1 plus 55. I'm also going to do 4 times 3 squared plus 32 times 3 plus 55. That will get me the answers for my range down here. So our frame, if our frame was a 1 inch by 1 inch frame, our total area would be 91. If our frame was a 3 inch by 3 inch frame, our total area would be 187. And that's the answers to 13 and 14. Okay, and number 15, we're looking at the rate of change. We're looking to see if this function is linear, quadratic, or exponential. So if it says the rate of change of function f is the same from -2 to 1 as it is from 1. So this change, whatever this is the same as it is from 1 to 4. So if these changes are all the same, that means that's the first difference, which is the same, then these are all linear, or this is a linear function. Remember, first difference is linear. The second difference is quadratic. And then the ratio of y's is exponential. Okay, number 16, we're looking at which function best models the data. Okay, so we have a table, and we're going to start looking at the values of the table. We know that when t or x is 0, then h or y is 3. And whenever x is 0 and y is a number, that is our y-intercept. And in standard form, C is our y-intercept. So I already know that net 3 is basically going to be C. Now, remember, this says which one best models the data, meaning this is not going to be perfect. So I automatically know it cannot be A or D because their C's are way too big. 2.99 is a good estimate for our C. Now, I know that my B's are the same value, so I'm not going to worry about those, and we're just going to look at B and C, and we're going to compare it to what's going on here. Because my values change, we're going up, looking at Y's. We're going up, and then down. That tells me this right here is my vertex or my turnaround point. I can use that information to solve my problem. I also know that what I'm missing is A. So there's two different things I could do. I can plug this information into an equation using X and Y values from my table to solve. I could also plug it into this equation here, okay, because I'm trying to find A. So I'm going to probably do this one down here. I think it'll be faster, but you could do either equation. And then for my X value, I'm just going to use 1. So I'm going to use this right here for X. And I'm going to plug it in. So 1 is here. I'm going to multiply both sides by 2 to get rid of the 2 on the bottom. Well, actually 2a to get rid of that and get negative 10.22. Then I'll divide by the number 2, and I'll get that a is equal to negative 5.11. So having this information, again, we're looking at closest. It makes more sense that C is our answer because it is closer to the value of A that we received than the negative 16.1. So C is our answer. Okay, skipping 17 and 18. For 19, you're going to go ahead and plug in these intervals for x in both of the functions, and you'll find that D is the one that increases. F of x increases during this interval faster than G of x does. And then for number 20, you're just trying to identify linear, exponential, or quadratic, and you're looking at the differences. Now, unfortunately, this one is none, because when I start subtracting, I don't have a first difference, a second difference, but also when I do the ratios, they're not the same either. But that's what you're looking for, is subtracting the y values from each other or putting them as ratios to see which one model matches. So you can see here, first differences, second differences, ratio.